Let me ask you something. What happens when you drop a ball? It falls. Obviously. You knew that when you were 2 years old. Gravity. Done. Case closed. Except it is not closed. Not even a little bit. Because I am going to take that simple, obvious, completely settled fact, and I am going to show you that almost everything you think you know about it is wrong. And not just a little wrong. Wrong in deep, surprising, beautiful ways that tell you something about the nature of knowledge itself. Let us start with the most basic possible question. Why does the ball fall? You say gravity. Fine. What is gravity? Isaac Newton told us in 1687. He published a book, arguably the most important book in the history of science. Every object in the universe attracts every other object with a force proportional to the product of their masses, and inversely proportional to the square of the distance between them. That is the law. Clean, elegant, and it works magnificently. You can use it to predict the motion of the planets. You can use it to aim a cannonball. You can use it to figure out how fast a ball will be falling after 1 second, 2 seconds, 3 seconds. For over 200 years, Newton's law was the gold standard of physics. It predicted the existence of Neptune before anyone had seen it. They noticed irregularities in the orbit of Uranus, ran Newton's calculations, pointed the telescope at the right spot, and there it was. A whole planet, discovered by mathematics. If that is not impressive, I do not know what is. But Newton himself did not like his own theory. He saw the problem. He wrote to Richard Bentley in 1692 that the idea of one body acting on another through empty space, with nothing in between to carry the force, was so absurd that no thinking man could accept it. How does the Earth know the ball is there? How does the sun know where the planets are? If I move the Earth, does the force change instantly, everywhere, at infinite speed? Newton's theory says yes. He called it action at a distance, and he hated it. The equations were beautiful, the predictions were accurate, and the fundamental picture made no sense. So Newton's gravity is wrong? Yes. In 1915, Albert Einstein published his general theory of relativity, and he showed that gravity is not a force at all. There is no invisible hand reaching out from the Earth and pulling your ball downward. What is actually happening is far stranger. The Earth, because it has mass, is warping the fabric of space and time around it, bending the geometry of the universe itself. And the ball, when you release it, is not being pulled by anything. It is simply following the straightest possible path through curved space-time. It is doing what any object does when no forces act on it, moving in a straight line. But a straight line in curved space-time looks, to you standing on the ground, like a ball falling. This is not a minor correction. This is not Newton plus a tweak. Newton says there is a force. Einstein says there is no force. Newton says space is flat and passive, just a stage on which things happen. Einstein says space itself is a dynamic, bending participant in the physics. Two totally different pictures of reality. And Mercury proves it. Mercury's orbit has a tiny extra precession, about 43 arc-seconds per century, that Newton cannot explain. Leverrier, who had predicted Neptune from similar discrepancies, proposed a hidden planet called Vulcan to explain Mercury. People searched for it. Some even claimed to see it. But Vulcan does not exist. Einstein's equations predict those 43 arc-seconds exactly. When he finished that calculation in November of 1915, he said he had palpitations of the heart. He knew. And here is the thing that should really bother you. Newton's theory worked. It worked brilliantly for 200 years. It predicted planets. It predicted eclipses. It got human beings from the surface of the Earth to the orbit of the Moon. And yet, it was wrong. Not wrong in the sense that it gave incorrect answers for most purposes, because the answers were perfectly good. Wrong in the sense that its fundamental picture of reality, the idea of gravity as a force acting through empty space, is just not what is happening. So let me ask you, when you learned in school that gravity is a force that pulls things down, were you learning physics? Or were you learning a useful lie? I would say you were learning a useful lie, and I would say that almost everything in physics is a useful lie. Now do not throw things at me. Let me explain what I mean. The lies get better and better. They get closer and closer to the truth, but they never quite arrive. And that is the pattern I want you to see today, because it runs through the entire history of the subject. So Einstein is right, and Newton is wrong. Case closed, this time for real. Wrong again. Einstein's theory is classical. It does not include quantum mechanics. And we know that the universe is fundamentally quantum mechanical. When you try to apply quantum mechanics to gravity, you get nonsense. Infinities that cannot be removed. The theory breaks down completely. At the center of a black hole, where gravity is extreme and the distances are tiny, both quantum mechanics and general relativity claim jurisdiction and both fail. Something deeper is going on. Einstein must be an approximation to some theory that nobody has figured out yet. Just as Newton was an approximation to Einstein, Einstein must be an approximation to whatever comes next. So now we have 3 layers, and we have not left the falling ball. A force called gravity. Wrong, but useful. Curved space-time. Better, but also wrong at the deepest level. Something we have not figured out yet. And now I want you to feel something. I want you to feel the vertigo of this. Because this pattern, where every answer turns out to be wrong and is replaced by a better answer that is also wrong, is not an accident. It is not a bug in physics. It is physics. It is the entire history of the subject. Consider atoms. What are things made of? The ancient Greeks said 4 elements: earth, water, air, fire. That was wrong, obviously. Then the chemists found real elements: hydrogen, oxygen, carbon, iron. 92 naturally occurring elements, each made of atoms. Little indivisible particles. The word atom comes from the Greek for uncuttable. Fundamental. Final. Done. Wrong. In 1897, J.J. Thomson discovered the electron. Atoms are not indivisible. They have parts. Thomson proposed a model where the atom was like a plum pudding, electrons embedded in a blob of positive charge. A reasonable guess. Wrong. In 1911, Rutherford fired alpha particles at a thin gold foil. Most sailed straight through, as if the gold were not there. But a few, a very few, came bouncing back at wild angles. Rutherford said it was as if you had fired an artillery shell at tissue paper and it bounced back and hit you. Something tiny and incredibly dense was hiding inside. The atom is mostly empty space, with a dense nucleus at the center and electrons orbiting like planets around a tiny sun. Wrong. And wrong in an interesting way. An orbiting electron is an accelerating charge. According to Maxwell's equations, it should radiate energy continuously, spiral inward, and crash into the nucleus in a fraction of a second. Every atom in the universe should collapse instantly. Obviously, they do not, which means the solar system model cannot be right. Niels Bohr fixed this in 1913 by decree. He simply declared that electrons can only exist at certain specific energy levels. They cannot spiral. They jump. Why? He could not say. He just announced it, the way a king announces a new law. And it worked. It explained the spectral lines of hydrogen with stunning precision. Wrong again. In the 1920s, Heisenberg, Schrödinger, Dirac, and Born developed quantum mechanics, and they showed that electrons do not orbit at all. They do not have trajectories. They exist in probability clouds, wave functions that tell you the likelihood of finding the electron here or there, but that do not describe any definite path. The very picture of an electron circling a nucleus is just not what is happening. 5 models. All wrong. each necessary, each an improvement on the last. Or consider light. Newton said it was a stream of tiny particles, corpuscles, traveling in straight lines. Seemed reasonable. Newton was Newton, so people believed him for a long time. Wrong. Thomas Young showed interference patterns in 1803. Bright bands and dark bands, exactly like water waves passing through two openings. If you fire bullets through two slits, you get two clusters of holes. Light does not do that. Light forms bands. That is a wave. But what is it a wave of? Scientists proposed the luminiferous ether, an invisible substance filling all of space, stiffer than steel to transmit waves at the speed of light, yet perfectly transparent, so planets could move through it. Wrong. Michelson and Morley in 1887 searched for the ether with exquisite precision and found nothing. No ether. Maxwell had already shown light is electromagnetic waves, self-sustaining oscillations of electric and magnetic fields in vacuum. No medium needed. Wrong. Einstein in 1905 showed light comes in discrete quanta, little bundles of energy that behave like the very particles Newton proposed and Young refuted. So light is not a wave and not a particle. It is somehow both, depending on the experiment. Wave-particle duality. Nobody really understands it. We know the rules for calculating. We do not have a comfortable picture of what light actually is. Particles. Wrong. Waves. Wrong. Waves in ether. Wrong. Electromagnetic waves in vacuum. Partly right. Particles again. Also partly right. Both at once. As right as we can manage, and deeply confusing. Now I want you to notice something. In every one of these stories, the wrong answer was not random. It was not a wild guess that happened to fail. It was the best possible answer given the evidence available at the time. Newton's gravity was the most brilliant thing anyone had ever done. The plum-pudding atom was a perfectly logical response to the discovery of the electron. The ether was the only reasonable explanation for how a wave could travel through empty space. These were not stupid ideas. They were very smart ideas that turned out to be incomplete. And that is a crucial distinction. There is a difference between being wrong because you are careless and being wrong because nature is deeper than you expected. The first kind of wrongness is a failure. The second kind is the normal condition of science. It is how we learn. Every wrong theory, if it is wrong in the right way, teaches us something that we could not have learned any other way. Let me show you two more examples, because they illustrate this beautifully. Or consider heat. For centuries, scientists believed heat was a fluid called caloric. Lavoisier, the father of modern chemistry, put caloric in his table of elements alongside oxygen and hydrogen. He thought it was a real substance. Then Count Rumford bored cannons in 1798 and noticed something peculiar. The drilling produced an enormous amount of heat, an inexhaustible amount. He could boil water with the friction. If caloric were a substance stored in the metal, it should eventually run out. But it never did. Heat is not a substance. Heat is motion. Atoms jiggling. One of the greatest chemists who ever lived had a fictitious substance in his periodic table. Or consider mass. A ball weighs the same whether moving or still. Mass is constant, independent of speed. That is what Newton says. Everyone believed it for centuries. Nobody even questioned it. It seemed as obvious as anything in physics. Wrong. Einstein showed mass increases with speed. At everyday speeds, the change is so incredibly tiny that no instrument on Earth could detect it. A ball thrown at 60 miles per hour gains so little mass that you would need instruments millions of times more precise than anything we have. But at 90% of the speed of light, mass has roughly doubled. At 99%, it has increased by a factor of about 7. And as you approach the speed of light itself, the mass increases without limit, which is why no object with mass can ever reach it. And here is the profound part. This small correction revealed that mass and energy are the same thing measured in different units. E equals mc squared. The distinction between matter and energy, which seemed absolutely fundamental, is an illusion created by the fact that we live in a slow-moving world. A very small correction to a wrong law revealed one of the deepest truths in all of science. Every single answer was wrong, and each wrong answer was a stepping stone to a less wrong answer. Now let me ask you to really feel that. Gravity. Wrong. Atoms. Wrong. Light. Wrong. Heat. Wrong. Mass. Wrong. And we could keep going. People thought time was absolute, the same everywhere, ticking at the same rate throughout the universe. Wrong. Einstein showed time is relative. It runs at different rates depending on speed and gravity. Clocks on airplanes tick slower than clocks on the ground. If you do not correct for this in satellite navigation systems, the positions drift by kilometers per day. Newton's absolute time is a useful lie. People thought empty space was truly empty. Wrong. The quantum vacuum seethes with virtual particles popping in and out of existence. Two metal plates placed very close together feel a measurable force from these fluctuations. The Casimir effect. Nothing is not nothing. Every single thing you think you know about the physical world, if you trace it back far enough, rests on a theory that turned out to be an approximation to something deeper. There is no exception. Physics does not progress from wrong to right. It progresses from wrong to less wrong. Every theory we have ever had has been wrong. Every theory we have now is wrong. And every theory we will ever have will be wrong. The only thing that changes is the degree of wrongness. That sounds depressing. It should not be. Because the approximations are magnificent. Newton's wrong theory took us to the moon. Maxwell's wrong equations power every electrical device on the planet. Quantum electrodynamics, which I helped develop, and which is certainly wrong at some deeper level, predicts the magnetic moment of the electron to 10 decimal places. That is like predicting the distance from New York to Los Angeles, accurate to less than the width of a hair. And there is something remarkable about this progression. The old theory is always contained inside the new one. Newton does not disappear when Einstein arrives. He becomes a special case. Take Einstein's equations, assume weak gravity and slow speeds, and Newton falls right out. Classical mechanics does not vanish with quantum mechanics. It emerges as the limit when objects are large. This is called the correspondence principle, and it tells you that wrong theories are not random guesses. They capture something genuinely real about nature in a certain domain. They just do not capture everything. So when I say that most of physics is wrong, I do not mean physics is unreliable. I mean the opposite. Physics is the most reliable form of knowledge that exists. And the reason is precisely that it keeps finding out it is wrong and fixing itself. A body of knowledge that never changes is not reliable. It is dead. Living knowledge grows by finding its own mistakes. And that, I think, is one of the most important ideas in all of human thought, not just in physics, in everything, because it changes how you think about knowledge. If you think knowledge means being right, then every time a theory is overturned, it looks like a failure. How can we trust science if it keeps changing its mind? But the changing of minds is not a weakness. It is the defining feature of science. It is the thing that separates science from dogma. A dogma says, here is the truth given by authority, and it will never change. Science says, here is our best guess, and we fully expect it to be improved upon. If Newton had been right, if his theory were the exact final truth, then physics would have ended in 1687. There would have been nothing left to discover. What a terrible fate. The only reason physics is exciting is that our theories are wrong. Wrongness is the fuel that drives the entire enterprise. I once gave a talk about what I call cargo cult science. During the war, islanders in the South Pacific saw planes land with wonderful goods. After the soldiers left, the islanders built runways out of wood, carved headphones from coconut shells, sat in mock control towers, and waited for the planes to return. Everything looked right. But no planes came. The form was there. The substance was not. I see the same thing when scientists stop asking whether they are wrong, when they fall in love with a beautiful theory and defend it against contrary evidence. The first principle is that you must not fool yourself, and you are the easiest person to fool. When a physicist starts protecting a theory from experiment, he has stopped doing physics. He has started doing cargo cult science. Being wrong is essential. Every giant in the field was wrong. Newton was wrong. Maxwell was wrong. Bohr was wrong. Einstein was wrong. I am wrong too, about things I have not yet figured out. The only people who are never wrong are the ones who are not doing anything. And every great breakthrough came from someone willing to say what we have now is wrong. Newton was willing to say Aristotle was wrong about motion. That took courage, because Aristotle had been the authority for nearly 2,000 years. Einstein was willing to say Newton was wrong about gravity. That took even more courage, because Newton was the most successful physicist who had ever lived. And whoever figures out quantum gravity will have to say Einstein was wrong, and they will be right. And someday, someone will say they were wrong too. That is the process. It never ends. There is no final theory. There is only deeper and less wrong. We know our current theories are incomplete. The standard model of particle physics has about 19 parameters, masses and coupling constants, that we cannot calculate from the theory. We just measure them and plug them in. Why those numbers? Why 3 generations of quarks and leptons instead of 2 or 4 or 17? The theory does not say. A theory with that many unexplained numbers is telling you something. It is telling you I am not the final answer. There is a deeper pattern, and you have not found it yet. What is that deeper pattern? Nobody knows. It might require us to abandon concepts we consider fundamental. Time, maybe, or space, or causality. Remember, nobody in Newton's time could have imagined curved space-time. Nobody before the 1920s could have imagined that particles do not have definite positions. The next revolution might be equally unimaginable to us. I sometimes think about what the physicists of the 22nd century will say about us. They will look at our theories the way we look at caloric. They will say, they thought space-time was smooth and continuous. How quaint! They could not even reconcile gravity with quantum mechanics. How did they manage? And they will be right. Our theories will seem primitive, not because we are stupid. Newton was not stupid, but the evidence is incomplete, and so the theories are incomplete. The ball falls. That will not change. But why it falls, what falling really means, what space and time and gravity actually are at the bottom of things, those questions are wide open. They have always been open. They will always be open. And that to me is the most wonderful thing about physics. Not that we have all the answers, that we keep finding better questions. So here is what I want you to take away. The next time someone tells you that physics has figured everything out, that we understand how the universe works, just smile and drop a ball and ask them to tell you, really tell you, with no useful lies and no approximations, exactly what happened and why. They cannot do it. Nobody can. And that is not a failure of physics. That is the glory of physics. Science is not the accumulation of right answers. It is the systematic elimination of wrong ones. And the faith, vindicated over 4 centuries, that the next less wrong answer will be even more magnificent than the last. What is the thing you feel most sure about? Whatever it is, ask yourself, what would it take to show that it is wrong? And what might replace it?